Welcome to this A-level lesson on the bubble sort algorithm from the D1 module. Now, if we just consider this list of numbers here, we need to sort them into ascending order. So we need to think about how we could do that. Now, first of all, we could of course just do that by inspection, where the list isn't very long, but that's really not the spirit of D1. We need to learn algorithms that will solve these problems for us. I mean, imagine if you had a million numbers that you needed to sort into order. You would need an algorithm that you perhaps then program into a computer. So we're looking for a sorting algorithm. There are many sorting algorithms. If you just were to Google them, you'd find lots and lots of different ones, some quicker, some more efficient than others. But you need to know two algorithms for the Edexcel D1 exam, and the first one I'm going to discuss is the bubble sort algorithm. Now, this works by you comparing each number side by side. So we're going to sort this into ascending order. So what I want you to imagine is the big numbers are going to have to float to the top. So always remember that the big numbers are going to the top there. So first of all, what we do is we just start with the first two numbers, and we're just going to circle them. And we're just going to ask ourselves, is 25 bigger than 22? Well, of course it is. So that means that the 25 will jump over the 22. So now the 22 is here and the 25 is there. And we're going to have to copy out all of these numbers. They've not changed there. We've just made one comparison. Okay, so we only compare adjacent items, and we either swap them or we leave them. So we've done one comparison so far. So now we make another comparison and we move to here. And we're either going to swap them or we're just going to leave them. Now we're going into ascending order. So the big numbers need to go to the right hand side. So I'm quite happy with where 30 is. We're going to leave them on that occasion. But now we have to copy out this list again. And I know perhaps some of you are already thinking this is an awful lot of work, but there is a little shortcut which I'm going to show you shortly. So I've just missed the 5 there. And we move the bubble along one more time. So now we ask ourselves, should 30 jump over the 18? Is 30 bigger than 18? Of course it is. So it will jump over. So now 18 will be there and 30 will be here. And the bubble moves along again. Do we swap or do we leave alone? Of course, the big numbers need to gravitate to the right hand side. So it does jump over. And then the bubble moves along again. Do we swap that or do we leave it alone? Well, yes, 30 does need, in fact 30, you should see, will end up going all the way to the right hand side. So now we compare those two. Okay, so these are all called comparisons that we're doing. We're making the comparison here, and we're deciding to swap them. And there's just one more comparison on this pass that we need to do, and that's the one there. And indeed, there will be another swap. Right, we have done one complete pass. Now that was a lot of work. It's not actually the most efficient sorting algorithm out there. But luckily, we don't normally have to show each comparison as we did there. You may sometimes be asked to do that just once on one complete pass, as I've done there, but you'll never be expected to do that every single time. The list is still not sorted. We need to go through that process again, but they will normally just allow you to just show the state of the list after one of those passes. So what we can do is I'm going to start the process again. Now imagine we're comparing there. Will 22 make it over 25? Well, no, it won't. So now you compare there. Will 25 make it over 18? Yes, it will. Now from that we know that 22 is going to stay there. We know that 18 will definitely stay there. Now we've got hold of the 25 at the moment. Will 25 jump over the 29? Well, no, it won't. So we now know that 25 is there. Now we're picking up the 29. Will 29 make it over the 21? Yes, it will. But that means that we now know where 21 is. Will the 29 make it over the 27? Yes, it will. So we know that the 27 is going to be there. Will the 29 make it over the second 21 there? Yes, it will. So the 21 is going to be there. And then will the 29 make it over the 30? Well, no, it won't. So we know it's going to be there. So what we've actually done there is made lots of comparisons, but we've not shown them, but we've done a second complete pass. So that's what you'd be expected to show normally in the exam. So next, we're going to start this again. This will be our first comparison. You can see how far the 22 is going to get. It's going to get stopped in its tracks by that 25, but it will jump over the 18. It will then stop there. Now pick up the 25. You can see it's going to jump over the 21, so we know the 21 is going to be there, but it's not going to make it over that 27. Now focus on the 27. Will it make it over that 21? Yes, it will. Will it make it over that 29? Well, no, it won't. So now we pick up the 29. Of course, it's not going to jump over the 30. So we've done our second comparison. So you see, with a bit of practice, you will get quicker at implementing this algorithm. So we've done 3 complete passes now. So first comparison, 18, it's not going to make it over the 22. Pick up the 22 then, that will make it over the 21. The 22 is not going to make it over the 25, so we know to stop there. Now pick up the 25, it will make it over that 21, look. So the 25 will be settled there, so it's not going to make it over the 27. And you can actually just see that the list is actually in order, these last 3. So you don't necessarily have to go through those comparisons in your head. You can just kind of cheat. No one will know that you didn't do the comparisons. So again, the list is almost in order, but we're not allowed to use our own human judgment on that. More on that in a second. So the 18 will stay where it is. Pick up the 21. Will that make it over the 22? Well, no. But pick up the 22. Will that make it over the 21? Yes. But then the 22 does not make it over the 25, and we can actually see that the rest of the list there is in order. So I'm not going to make all these comparisons, I'm just going to write the list. Now, you can actually see now the list is sorted. It's in order. The 5th pass produced a list that was in order, but the algorithm doesn't know that yet. We've used our own human judgment. On that previous pass, there was an actual swap, and you can only stop and terminate the algorithm once you've gone through a complete pass and nothing has changed. So you would be expected to do this all again. Now nothing will change if you do all the comparisons. Nothing's going to change there. Well, you could possibly swap the 21s around. I'd leave that up to you. But nothing changes. So on the 6th pass, there were no exchanges at all. Therefore, we now know that the list is sorted. So we need to put that. No exchanges, there's no swaps, use exchanges or swaps, something like that. Therefore, the list is sorted. Okay, you mustn't use your own human judgment. You must do that extra pass showing that there were no swaps at all. Okay, so that's the bubble sort. Let's just show that in full. Again, just let me remind you that on the first pass we showed each comparison. Like I've already mentioned, the maximum you'd be expected to do that is just normally on the first pass. You will generally be doing this just showing the state of the list after each pass, but you really need to just read the question with regards to what it actually wants you to do. There are some questions now for you. So we've got a question here. So perhaps if you'd like to pause the video. And we've got another question here. I think I've got 5 questions in total, including quite a mean question 5. There's question 3. So you can get questions that use names. So obviously you're just comparing letters of the alphabet there. And sorry, question 4 must be down here. It's an interesting question here, getting you to think about the worst case scenario for a set of numbers, the one that requires you to do the most work. And really an extension question, question 5. You'll never get a question as long as this in the exam, but I think it's really good practice for you to do one that's so long. So I'm going to reveal the answers to all of those now. That's what I should have got for question 1. Question 2 there. Again, do write a little comment at the end showing that there's been no exchanges, therefore you know the list is sorted. Question 3. Interesting question 4 there. And yes, I had lots of fun doing this one, as you can see. But it really is, I think, good practice in doing such a long question. I think that you're really forced to build up your accuracy and build up your verification strategies. Okay, I hope you enjoyed Bubble Sort.